So, we are going to zoom. Oh, no. There. All right. Can everybody see my display? All right. So, we are going to, if you guys remember the lesson we did last Friday, what did we do? What did we do on Friday?
I wasn't here.
Well, what did we do? As in everybody else other than you. Did you watch the video? Okay. What did we do on Friday? Somebody that was here. That's part of it. What was the first half of what we did on Friday?
Yeah, that's all we did.
Oh, yeah. No. Shoot. I'm stupid. Thursday. What did we do Thursday? Right, Jeff? I said it. You don't have to. I said it. What did we do Thursday, though? That's something to do with triangles, didn't it?
Yeah.
What did we do? We did the 30, 60, 90 triangle, right? And what else did we do? We did another one, didn't we, Jasmine? 45, 45, 90. So, our first exercise, our opening exercise, is to find the lengths of the sides of the triangles below, each of which has a hypotenuse of length 1. So, what were our lengths? What were our lengths given a... If this is 30 and this is 90, what does this have to be? Has to be 60, right? Can't be anything else, can it? Because it's a triangle, and we're in Euclidean space. I know you guys don't know what Euclidean means, but trust me. Trust me, in about 2,000 years, they figure out that this isn't universal. But, anyhow, so this is 60 degrees, right? Pretty much. Not pretty much, exactly. Exactly, not pretty much 60. Exactly 60. Okay. All right. So, that means this is 60 degrees. All right. If this is 45 degrees, and this is 90, that must be 45, right, Caleb? 45 degrees. And then, if this is 60, and this is 90, Stephen, what must this be? I'm doing it without looking, so I don't know if I'm slightly off, but if this is 60, and this is 90, what must this angle be? 30. Can't be anything else, right? Okay, so go back to your notes that you took on plain paper Thursday. If this hypotenuse is 1, what must this side be? And what must this side be? Let's see how good your note-taking is. How good's our note-taking? So, if this is 30, and this side is 1, what must this side be? And what must that side be? Check your notes, see if you got that. Give me a length. What does the length have to be? You were here for this one. You were here for this one. So what did we find our lengths to be?
Yeah.
What does this length have to be? Who's got those lengths in their notes? Tattooed on the back sides of their eyelids. Like me. You don't believe me, Kaya? Should I show you? You believe me then? Okay. All right. Who's got some input here? Who's got this in their notes? I got one person here. So what's the length of this side, Liv? What's the length of this side right here? The side, well, we didn't find x's. We found a value for x. Mason, what's this side right here? 1/2. We do that in red. That is 1/2. Okay. What was this other side in our notes? Jasmine. Square root of 3 over 2. I'm going to do that in blue. Okay. What about, let's skip the one in the middle. Let's go over here. What's this side length here, Taylor? Square root of 3 over 2. If we think about this, this is just kind of, this is really just this angle flipped on its side, right? What kind of translations have I made from this triangle to this triangle? What translations, Mason? Give me one. That's a reflection. It's a reflection. That's one transformation. What's another transformation? Rotation. And then, what's the one where you move it? That's a translation, right? So if this is 3/2, Sophie, what's this? 1/2. I'm going to do that in red. Okay. How about the sides of my 45, 45, 90? What do we get, Tyler? What do we get here and here? What do I know about the relationship of this side as compared to this side? What do they have to be in relation to one another? Oh, I heard it. Somebody said it. They're the same. Why are they the same, Caleb? Their corresponding angles are the same. So then the sides have to be the same. What were those side lengths? Square root of 2 over 2. I'll do that in green. Square root of 2 over 2 and square root of 2 over 2. Okay. Good. Now, now you should have calculator practice here. Actually, yeah, calculator. Well, no, not calculator practice. Given the following right triangle, ABC, with angle A equaling theta, this circle with the line through it, like that, it's Greek letter theta. Greek letter theta. We like that for angle measurement. We also like angle alpha, and we like angle beta. You know beta is different from B because of the big tail. I've kind of exaggerated my tail, but you'll usually see the tail about yay long. That's beta. All right? But this one's theta. Now, this is the first time I've given this to you, so listen up. This will help you for the next 2 to 3 years in math, depending on how long you decide to stay in it. Actually, you probably know this already from geometry, but you guys see that last year in geometry?
I wasn't in geometry.
I'm in geometry.
Yeah.
Okay. So about 5 of you are in geometry right now. You'll also hear it in its culturally insensitive mnemonic. So, Toa. You're doing that in geometry right now?
No clue what this means.
So,
I'm not in geometry. I haven't been in geometry.
that is interesting. We've gone over this before, haven't we, you and I?
Well,
We've talked about
I
it.
signed up for geometry and trigonometry too. So I have no clue what this means. I'm sorry.
That's okay. That's okay. Now, what does that mean? What does this mean? What does the S stand for here, Camden? Yeah, keep the your please. And the C, Isabel. And the T, Jesse. Tangent, thank you. I need your eyes up here, okay? Now, in order to find sine, I take the length of the opposite side. Meaning, if I'm finding theta, if I'm finding the sine of theta, what side is opposite of the angle theta? Which length? 5, right? And then over, or divided by, what does H stand for? Hypotenuse. And do we know, Liv, do you know what hypotenuse means?
It's like massage.
It's the long side of the triangle.
Yeah.
The longest side of a right triangle, right? Now, here's the trick. None of these will work unless you have a right triangle. Okay? You need a right triangle. So to find the sine of theta, what's sine of theta going to be? It's going to be opposite over hypotenuse. What's the opposite side? How long is it?
5.
So sine of theta equals opposite over hypotenuse,
5.
which is 5 over 13. You are done finding sine of that angle. What about cosine of this angle? 12 over 13. So cosine of theta equals, now I'm going to show you how I want you to show your work, how I want you to express your reasoning. You can write opposite over hypotenuse. You don't, oh snap, thanks Anthony. I knew I had you here for a reason. Cosine is not opposite over hypotenuse, is it? It's adjacent. Adjacent. Adjacent over hypotenuse. But you do not have to write the whole word adjacent. And you do not have to write the whole word hypotenuse. You can just go A over H. What is the adjacent side on this triangle? But isn't this adjacent? I mean, theta's right here. 13 is next to it. That's adjacent, right? Oh, so adjacent is the side next to my angle that is not the hypotenuse. So 12, I almost did it, over 13. Okay. So that is cosine of an angle. For now, I want you guys to include this step when you're finding sine, cosine, tangent, okay? Next page.
What does the X stand for?
Opposite. Now, the title of this lesson is translating, it's from circleometry to trigonometry, right? And we were asking, what the heck do those triangles that we worked on Thursday have to do with the circles that we worked on Wednesday? And we're about to get there. Let's pretend we're on a unit circle. What is a unit circle? Unit circle. I want you to write this in your notes. Unit circle is a circle with radius equal to 1 and center at the origin, 0, 0. That is a unit circle. And what it's going to allow us to do is it's going to allow us to get an understanding of how trig functions, functions that I use to find the sides of triangles, also helps me understand circles. Radius equals 1, and my center is at the origin. So where's this edge right here? If the radius is 1 and the center is 0, 0, where's this edge right here? X is what? No. It's xy, not yx. 1, 0. This point right here is 1, 0. What's this point right here? The red one. What's that point right there, Jordan? Yeah, what's the coordinates of the point? Well, my circle has radius 1 and centers at the origin. So how far is this distance right there? Huh? What's the... This is a radius, right? So how long's my radius? My radius is what? 1. So what's this point? Point's got 2 coordinates, right? Thank you. 0, 1. What is, do this one in blue. What's that point? Kaya. What's this point right here? What's my x coordinate right here? Remember, this point is 1, 0, right? I'm going -1. And how high is it going? Not going up at all, right? And Trey, last point. Last point. What's that point's coordinates? Green one. 0. It's going down, right? So it's 0, -1. Okay. Now, Jesse, what color do you want? Let's do baby turd yellow right there. What is the length of this? What's the length of that right there? It's asking, I'm asking, what's the length of this hypotenuse? I heard it over here, but I'm asking Jesse, what's the radius of my circle? 1. So what's the length of this piece right here? 1. Okay, so my length is radius equals 1. Good. Now, what's my angle? What's my radius? Oh, I'm sorry, what's my angle right here? What's my angle right here? 30, right? Now, let's go back to our first page of our notes in this lesson. What does this side have to be? What's the length of this side have to be? If my hypotenuse is 1, what does the length of this side have to be? 1/2. I'm going to do that in... going to do it in that turquoisey thing. So this is 1/2, right? And what should I do next? I'm going to do purple. I'm a Viking fan. Purple. What's that, Ethan? Square root of 3 over 2 right here. So now, oh no, baby turd yellow, that one. Now, what is the sine of my angle? What's the sine? How do I find sine? Sine equals opposite over hypotenuse. And what is the opposite side here, Ethan? 1/2. That turquoisey thing, right? Right there. One. No, that's not the one. Different one. This one? No, that one. 1/2 over. And what's my hypotenuse? 1. So what is the sine of my angle? Simplify that fraction. 1/2, right, Sophie? So the sine of 30 degrees equals 1/2. Who's got a calculator here? Punch in 30, sine, enter. Or if your calculator does it funky, do sine 30, enter. And tell me what you get. Point what? 0.5. Now, I want to show you guys something. I'm going to show it to you on my, wow, look at that. So, some of you guys will have this button on here that says mode. Who sees a mode button on their calculator? Okay, let me see your calculator, Anthony. Okay, so when you hit that button, the first thing you're going to see is normal, sine, ends. You don't worry about that. You don't worry about your slope, but you worry about the third line. You see radians and degree. You want to make sure this is on degree, because right now, if I did this right now, let me turn this off, because I don't know how to exit, and then turn it back on again. If I did sine of 30, I am not getting 0.5, am I? I'm getting 0.988. What that's saying is that's the sine of 30 radians, which is a different unit of measure for angle measurement. Okay? You want to make sure you're in degrees. So you go to mode, and you hit, go down, and you go over to degree, and hit enter. Now, that's for the scientific calculators, right? How do I exit out of this? I forget.
Press clear.
Press clear? Thank you. Now when I put in sine of 30, enter, now I get 0.5, okay? Everybody's calculator is going to be different depending on what model you have, okay? Some of them will just see, listen, you'll just see a deg, rad, or grad, either above the numbers or below the numbers. Who sees a DEG, an RAD, or a GRAD? Yeah, you're in degree. Good. Go ahead and turn yours on, Liv. So you're in DEG. You see that? That's where you want to be. If you hit this number, this button, then you can change it. But you want to be in degree right now. So we're just going to clear out of that. You want to make sure you're in degree when you start hitting these numbers. Okay? Now let's scroll down. We've already found the length of our right triangle, right? We said that was root 3 over 2, thanks to Ethan's acumen. And we said, what is the length of QP from the vertical leg? We already said that was 1/2. I believe that was also Ethan. You are on a roll. And we found the sine of 30 degrees as well, which we said was 1/2. Mr. Cook here. He is not. Okay? And we said the sine of 30 equaled 0.5. What's the cosine of 30? What's the cosine of 30? Do I need to go through that? Can I just do root 3 over 2 divided by 1? Let me ask you this. What did you say cosine of 30 was? 0.866 something, something, something?
Yeah.
So, if I take square root of 3 and divide it by 2, do you think I'm going to get that? I bet you do it, or you're banking on me? You're banking on me, huh? All right. So, square root of 3 divided by 2. Enter. Oh, no, that's not divided by 2. That's times 2. I want to do square root of 3, parentheses, divided by 2. Enter. Look at that. I get the same thing. So, cosine is root 3 over 2, which equals 0.866. Mr. Erickson's going to be upset with me because they got here and we didn't. I do not. I am done with classes.